My name is Sean, and today I'll be presenting my midterm project on Java. So the first part of my assignment, which was titled or labeled Lottery Statistics, it explained how a Powerball lottery works, and it gave me a file, PB numbers.txt, that has lines of draws from February 3rd, 2010 to May 11, 2016. Each line in the file has a set of 6 numbers that were selected on a given date, and they have a space in between them. So the first 5 numbers the user could have picked from 1 through 69, and for the Powerball number they could pick from 1 through 35. Now the assignment asked me to display the 10 most common numbers ordered by frequency, and the 10 least common numbers also ordered by frequency, and to display the 10 most overdue numbers, and then to display the frequency of each number 1 through 69 and the frequency of each Powerball 1 through 35. Now I can go over to my program where I am importing everything from the java.io and everything from the java.util, and then created my class, created my main method, and I'm declaring that the main method might throw an IO exception. Then first thing I did was I declared 3 arrays: a regular frequency for the first 5 numbers in a line in the file, a power frequency for the last number, the 6th number, to store the frequency of each number from 1 to 35, and then last scene, which is a array used to track when last each number appeared. Then now we're going to use the arrays.fill method to fill all 70 elements to -1. Then we're using the scanner file to open the pb numbers.txt, setting the draw to 0 because we haven't went through a line of the file as yet. Then while the file has a line, we're going to assign a line, one line to string line. Then we're going to get rid of the white space with a line.trim, that split method. This removes the white space, so we're going to have the number 135 all together. Then now we're going to loop through each numbers in the line, and we're going to convert them to integers. Then we can then use our array and whichever number we're using, because we know we have a range from 1 through 69, so we can just loop through each line and store the frequency of each number. And we're doing the same. We're not doing the same, but we're assigning the draw to the number to store when it was last drawn. Then now we're doing the same thing for the power method. First we convert it to an integer, and then we're incrementing each number's frequency. Then we just increment the draw for each line. Close our file because we got all the information. Then now we can go ahead and print the frequency of the numbers from 1 through 69. So for the first 5 numbers, we can print the frequency of each number. And to do this, we used a for loop. And we started with we initialized I to 1. And if I was less than or equal to 69, then we increment by 1. Then we print 1, and then we print the corresponding frequency of the number. Do the same thing for the Powerball number. Then down here, to start the list, we created a list, and this was used to store each element and their frequency. And then now we're using a for loop, 1 through 69 for the regular frequency. So again, for the first 5 numbers, and we're adding the element and their frequency. Then now we're using this to sort this array or this list, and this sorts it in descending order. So A represents the element and B represents the frequency, and we're using the frequency to sort it. Right. Then now we can use this list right here and print the first 10 of that sorted list, because we printed it in this it is in descending order, so the first 10 would be the highest frequencies, and then we'll just print numbers that has the highest frequency. Then we're doing the same thing for well, not the same thing, but vice versa for the least common numbers. We're just doing the reverse of what we did up here. As you can see, like A and B is flipped, so we're doing it in ascending order this time, and then we print the first 10 of that numbers list again. Then now we create another list for the overdue, to find the 10 most overdue numbers. Then we're using a for loop to scan through all the numbers 1 through 69. Then now we initialized a variable called gap, and essentially what we're doing is we're, based on the last time the number is seen, whichever number, whether 1 or 25, whichever iteration we're at, we're subtracting that from the draw, and then we're adding it to the list. Then we sort it in descending order and print the first 10. So that, and then I can run it now to show you guys how it looks. So the first thing we should have is the all the frequency of the first 5 numbers. So from 1 through 69, and here we can see all the frequencies. And you can see the powerball frequency 1 through 35. Then we can see the most common numbers, the least common numbers, and the most overdue numbers. Now we can move on to the second part of the assignment, which was a bank accounts class. So this assignment required me to create 2 classes, a bank account class and a savings account class that would be a subclass of the bank account class. So the bank account class would be an abstract class. Some fields of the bank account class would have been the balance, the number of deposits within a month, number of withdrawals, annual interest rate, monthly service charges. And right here I have all the information about what each method should do. So for example, the deposit method on the abstract class is a method that accepts an argument for the amount of a deposit. Then the method should add the argument to the account balance. It should also increment the variable holding the number of deposits. Okay, so I can move on to that method, and I'm going to start off with my abstract class. So first thing, I'm doing my import the scanner, because I know I'm going to take in some input, whether that be a value for a deposit or withdrawal. No, I should be doing my bank account. Let's start off with, this is my abstract class. So yeah, so I declared the class, used the abstract specifier, and I created all my data fields. So I created the balance to store the balance of the account, the number of the deposits to track each deposit of a month, number of withdrawals to track each withdrawal, because if the number of withdrawals go over 4, then the program the account should charge the user $1 for each time every withdrawal over 4. Annual interest rate, monthly service charges. Then we have our bank account constructor that takes two parameters, a balance and an interest rate. This is the annual interest rate, even though it says interest rate. And inside this constructor, so upon creation of an object, the balance is assigned to the private variable balance. Annual interest rate is assigned to the annual interest rate, the private variable annual interest rate. Then we're setting the number of deposits, number of withdrawals, and the monthly service charges to 0 to prevent garbage. Then now we have our accessor methods that basically just return the value of each of these variables. And we have a set monthly charge that sets the fee that the account should charge, the service fee that the account should charge. A set balance method, a deposit method that takes an parameter and assigns it to the balance, adds it to the balance. So if the user have $100 and they choose to deposit another $100, they'll add the $100 to this $100, and that will be $200. And we're also incrementing the number of deposits. So each time this method is called, the number of deposits goes up by 1. And we're basically doing the opposite of the deposit method with withdraw. We're taking a parameter also, but we're checking if the balance is greater than 0 for input validation, and then we're subtracting that amount from the balance, and then we're still incrementing the number of withdrawals. Calculate interest method, we're just using this method to calculate the monthly interest. So the first thing we do was declare a variable called monthly interest rate. Then we divided the annual interest rate by 12 because we want to get the monthly interest rate. And remember, the user gave us the annual interest rate. And then now we just use that interest rate times by the balance to get the monthly the interest rate for that month. However amount the user have in his bank account that month, create the interest for that month, and then we're added to the balance, and that's how we calculate the interest. Monthly process now, it checks if the balance is greater than 25, because if the balance of the account is less than 25, that means the account is inactive. And then it goes ahead and calls the calculate interest, so we can get the interest of the balance, number of deposits, and then it just resets the account. So set the number of deposits to 0, number of withdrawals to 0, number of monthly service charges to 0, so no monthly charges. Basically resets the whole account for a new month. Then now we can go over to our savings account class, which extends from the bank account abstract class. Then now the only private variable we have is a status boolean that stores whether the account is active or inactive. Then we have our constructor that takes the same parameters of the superclass, a balance and an annual interest rate. Then we're passing them as argument into the super constructor, balance and interest rate. We're also checking if the balance is greater than $25, and then we're setting the status to true. If not, we're setting the status to false. Then we have a get status method that returns a status whether the account is active or inactive. A withdraw method to withdraw some money from the account if the user wants to withdraw some money from the account. So in this method, we have a scanner input to take input, and we have a variable called funds. First, we're checking if the status is active, because if the account is inactive, the user cannot withdraw, they can only deposit into it. So if true, then we ask the user to enter how much they want to withdraw. Then we're calling the withdraw method with the funds, whatever they entered, as an argument. And then what does that do if you don't remember? It checks if the balance is greater than 0, And then, which it could be Greek. This is unnecessary. I can remove it right now because over here we're checking if the balance, we're checking if the status is true, and if it's the balance is 0, then the status would never be true. So that was unnecessary. And then now we can remove the amount from the balance. Then after the user withdraw, we're gonna check if the user withdraw enough money to make it the balance less than $25, and if that is true, then we're gonna assign false to the status and make the account inactive until the user deposits some more money that's more than $25. Else, if the status is false, then we're gonna go ahead and print to the user that you cannot withdraw from your account because it is inactive, and you may deposit an amount that's more than the current balance, and we're printing the current balance so the user can know how much they have into their account. Then we're calling deposit method. This method right here, which we're going to move on to, does the same thing. First, does the same thing as the withdraw method. It creates a scanner object, has a local variable called funds, data type double. Prompt the user to enter a value into funds. Then we're checking if the status, we're checking if the account is active to the status, if the status is true, or if the funds plus the balance is greater than the minimum the account can have. If either of these are true, then we call the superclass method deposit, passing the funds as an argument, and all that does is just adds the amount to the balance and increments the number of deposits excuse me, and set the status to true. Else, if both of these are false, then we're gonna tell the user that you must make your balance greater than $25, and then we prompt them to enter another value and try to deposit more money. And then we're creating a variable called current balance, calling the get balance method to return the balance, the current balance. And if the current balance plus the funds, the value of funds, is greater than the current balance, then we're calling the deposit method again and passing the funds as an argument. If not, we're gonna tell them that their deposit was too low. Then the monthly process method gets the number of withdrawals, assigns this to the number of withdrawals method local variable of the monthly process. Have a field declares and assign or initializes a fees variable with 0. Excuse me. And then if the number of withdrawals is greater than 4, we're going to use a for loop to track how many withdrawals above 4 the user did. And then for each withdrawal over 4, it costs $1. We're just assigning that to fees. Then now we're setting the monthly charge to fees from the superclass method. Set monthly charge. All that does is takes a parameter and assign it to the service fees variable or data field. And then now we're setting the balance by subtracting the field from the balance. And if the balance is less than 25, we're going to set the account to inactive by assigning false to the status. Then down here we're printing out the monthly service fees by calling the get monthly service charge, and we're calling the super monthly process method right here that checks the balance greater than 25. If that is true, then we're going to calculate the interest of the balance, and we'll reset everything for a new month. Now our program right here now, I can just run it to show you guys how it works. So first it asks me to enter a balance. I'm going to enter 500. Then it's going to ask me to enter annual interest rate. I'm going to enter 5%, so 0.05. Then now, it's prompting me to enter 1 to make deposits, 2 for withdrawals, and 3 to enter the program. So what I just did, where I'm at in the program right now is we already prompt the user to enter their balance right here and their annual interest rate. We created a we created an object of the savings account class, and we passed them arguments, the balance and the annual interest rate as arguments. Create a initialize a choice variable to 0, and while choice is not equal to 3, then we're going to go ahead and print all of these statements. So if the user chooses 1, then they can make a deposit, and it's going to make that deposit, call this method, then it's going to print out your new balance and your new status, if it changes. And if the user chooses 2, then we're going to withdraw from your account, and we're going to call the withdraw method and print the balance after the withdrawal if the account is active. Then we're going to print the status. And the 3, we're going to print the number of deposits, number of withdrawals. We're going to do the monthly process to get the interest and to reset the new month. And then we're going to print your balance and your status. Alright, now, so we're going to test. First, we're going to make a deposit. We're going to deposit $100. So now we have $600, and that account is true. Let's see what happens if we go below the 25 limit. So we're going to do 2 for a withdrawal. Then we're going to do 580. We're going to withdraw 580 from the account. So my new balance is 20, and as you can see, my account status is false, which means it's inactive. Then now I'm going to try to do another withdrawal, and this should not work because if your account balance is below 25, you can only make deposits because your account is inactive. And this should prompt me to enter a deposit. Excuse me. And there you have it. It prompted me to, it said you cannot withdraw from your account because it is inactive. You may deposit an amount that's more than your current balance. So since I have $20, I'm gonna just put $6 in there, and I have $26. If I try to do a withdrawal again, it should work, and it does. I'll just take $1. Then I'm gonna do 3 to end the program and print all of my information: my interest rate for the month, how many withdrawals I made, number of deposits, and stuff of that sort. So number of deposits, number of withdrawals is 2. Monthly service fee is 0 because we didn't go over the withdrawal limit. Current balance is 25, which is correct. That was the last thing they printed. And the status is true because we're not below $25. And that was all for my the second part of my assignment. For the third part of my assignment, we can go to the so this is the employee payroll class that excuse me, has data fields of the employee's name, ID number, hourly pay rate, and number of hours worked. So this assignment basically wanted me to use this information to create a program that use a class to create an object that would display the gross paid earned. Excuse me. That's the first class. That's the first part of the method. The second part of the assignment, sorry, part A, required me to write exception classes for the following error conditions. So for an empty string, for the employee's name or the employee's ID number, if the user for an invalid number is given for the number of hours worked. If it was negative or greater than 84, an invalid number was given for hourly pay rate. This would be a negative number or a negative or a number greater than 25. And it asked me to modify the payroll class. So I did everything in one. I just created the class with the exceptions classes, and as you can see them right here, they're very simple. So I'm going to go ahead and go to my payroll class first. So I have all my data fields up here. I have emp name, meaning employee name, emp ID, meaning employee ID, hourly rate, how much does the employee makes per hour, and the hours worked. Then we have a we have a constructor that takes the name and the ID. Then it's throwing an empty string exception, because this set name method throws on an an exception right here. So we have to put it in the constructor also. So inside our constructor, we're calling the set name, which call this method, and we can just go ahead to it right now. So all the set name method does is it declares that this method may throw a empty string exception, which is one I created. And what this basically does is just calls a super constructor on this exception and passes a string into it. Nothing crazy. Sorry, excuse me. Then now we can go back to our class. And yeah, declares that it may throw this exception. Now, if the name is null or it's empty, then we're gonna throw the exception and we're gonna pass the value that through the exception. Else we're just gonna assign the name to the private variable up there. Then now in our constructor, the set emp ID, so set the employee ID method uses the same exception and does the same thing because I used a string for my ID instead of numbers. So we can move on to our invalid hours exception, and it basically does all of these exceptions does the same thing. They just pass a string to the super constructor for the hours and just prints out some information to the user about why they got that error. And we're at our set hourly rate, so we're declaring that the method may throw an invalid pay rate exception if the pay rate is greater than 25 or less than 1, because we don't want their pay rate to be 0 or a negative number. Then we're going to throw that exception and we're going to pass the rate inside of it, the value of rate inside of it. Else we're just going to assign rate to hourly rate. Set hours, invalid hour, declare that it may throw an invalid hours exception. Checks if it needs to throw the expression. If not, we're just going to assign hours worked. Excuse me. Then now we have some accessor methods that just print out the value of the employee name, the employee ID, the hourly rate, and the hours worked. It just prints the value. Whenever these methods are called, they're printing the value of these variables. Now we can move on to our main function, since we got everything right there. And basically we just prompted the user to enter every piece of information for their name, their ID, that we call the object right here, or created the object right here. Pass the emp name and the ID because we need those for the constructor. Then we initialized two variables with the get hourly rate method and get hours worth method. So the get hourly rate method just takes a double. Returns a double for the hourly rate. Same thing for the get hours, takes an int and returns the int. Not takes an int, returns the int. Returns a int for the hours worked. And the get emp data returns a string. So there's just three different methods to make the code more modular. Not much, more modular. And one takes a string, one takes a double, and one takes a int. So I use this method for the two strings, this for the hourly rate, and that for the integer. Then now I put all of my statements right here inside of a try and catch block, so I can catch any exception these methods throw. Then I'm using multiple catch blocks because I have multiple exceptions. So the first exception I'm trying to catch is an empty string for the ID and the name, then an invalid pay rate and an invalid hours. And that's about it. And we can go ahead and run our method. So I say enter my name. For instance, my name is John. ID is 101. My hourly rate is $12. And then the hours worked. I made a mistake and I put 0. Let's see what it does. It throws an exception and it prompts me to start over and enter my information all over again. So enter John 01. Hourly rate was 12, and this time I work 60 hours. Then you print out all my information. My name was John, employee ID, hourly rate, hours worked, and this was the gross pay that they earned.